Hello, good day everyone. I am Ian P. Makalinaw and today we'll talk about the cloud application development. The increased demand for cloud-based applications has led to a consolidation of the cloud computing market, driving the need for cloud application development, which involves designing, building, and managing applications in cloud computing environments to leverage powerful resources and services for creating highly available, resilient, and flexible applications. So, at the end of these lessons, you should be able to learn the followings: assess benefits of cloud native architecture, clarify the distinctions between containerization platforms like Docker and orchestration platforms like Kubernetes. Explain how serverless computing differs from traditional server-based models, and analyze the benefits of using PHP RED pages. What is cloud native application? Cloud native application architecture involves building and running apps in the cloud, enabling companies to innovate, understand market trends, and respond quickly to customer requests. So, ano nga ba ang ibig sabihin nito? So, ang cloud native application is a software application na gumagana within the cloud, and it is hosted sa internet without using the physical server. And mas preferred din to gamitin ng mga companies dahil mas napapadali yung pag-deploy nila ng application, and mas nakakasabay pa sila sa market trends, as well as yung response nila sa kanilang customer is mabilis. Scheme of cloud native application. So as you can see here sa ating picture, we have the front end network and the back end. So sa front end, this is the client infrastructure, which is the UI or the user interface, kung ano yung nakikita ng ating client or user. And the network naman is, this is the kung saan naka-host yung ating application within the cloud. Then sa backend naman, we have the management, application, service, infrastructure, cloud runtime, storage, and security. So sa management, so let's say we have e-commerce application. So sa management, it's like a cPanel. We can monitor yung statistics ng data natin. Nakikita natin yung bandwidth, and we can configure our files, delete, edit, add, then we can monitor it. Then sa application naman, dito nangyayari yung user authentication, order processing, and other pa. And service naman, kung ano ba yung ino-offer ng application natin. Since e-commerce application, so ang service natin dyan is the user can order, the user can pay, and they can log in and register. Then sa infrastructure naman is, ito yung infrastructure like physical servers, yan, or even cloud, para masuportahan yung backend natin. Then sa storage naman is dito na i-store yung information ng client natin, like user details, order details, and the payment details. Okay. Then sa cloud runtime naman is, ito yung execution environment natin, kung saan nag-execute yung application natin. And the security is to keep our application secure. And pinaprotektahan niya yung mga files natin and gumagamit ng like HTTPS and SSL para secure yung ating information and databases. Cloud native application architecture comprises a front end and a back end. So, yun nga, the front end or the client side. And the back end naman or the server side.
The core design principles of cloud-native architecture. DevOps, a cultural framework for faster, more frequent and consistent software development, testing, and release. DevOps practices allows developers to shorten software development cycles without compromising on quality. Continuous integration and continuous delivery. Continuous integration automates code change integrations, allowing frequent merging into the central repository, while continuous delivery ensures reliable and automated software release process. Continuous integration, it allows developers to merge code more frequently into the central repository, while continuous delivery, organizations can quickly deliver individual updates, features, or entire products. Microservices, an architectural approach where applications are developed as small independent services, enabling development, upgrades, scaling, and restart independently. It usually as part of automated system allowing frequent updates to live applications without impacting customers. The next one is containerization. Software virtualization technique at the operating system level, minimizing resource usage by partitioning a single OS instance into isolated containers with unique file system and resource quotas. Creating and deleting containers and the high packing density in a single VM or virtual machine make containers an ideal computation tool for deploying individual microservices. So, what is the benefits of cloud-native architecture? The first one is loosely coupled services enable development teams to choose framework, languages, or systems. Allow development teams the flexibility to select various frameworks, languages, or systems for building software components independently. The next one is containerized microservice ensures organizations aren't overly reliant on any one cloud provider. Provide organizations with the flexibility to deploy and manage software components independently, reducing dependence on a single cloud provider. The next one is container orchestration platforms like Kubernetes make it easier to identify and address bugs without disrupting the entire application. Platforms like Kubernetes facilitate the efficient identification and resolution of bugs within applications, minimizing disruptions to the overall system. Next one is independent microservice allows developers to optimize each for core functionality, improve end user experience, empowers developers to optimize each for specific core functionalities, enhancing the end user experience through tailored and efficient microservice. Microservice facilitate continuous integrations and delivery, reducing development time and human error. Microservice enables continuous integration and delivery, streamlining development process and mitigating human error by allowing for smaller, more manageable code changes to deployed more frequently. The next one is container orchestrators automatically schedule and allocate resource-based demand, increasing efficiency. Schedule and allocate resources according to demand, enhancing operational efficiency by dynamically adjusting resource utilization. The next one is changes to one microservice or the addition of new functionality don't affect the entire application availability. Using updates to a single microservice or the introduction of new features do not impact the overall availability of the entire application thanks to the isolated nature of microservice architecture. So, if there's benefit, there's also challenges in cloud native architecture, which is it has four. The first one is managing distributed workflow and responsibilities without an established DevOps pipeline. Without an established DevOps pipeline, teams may have difficulty managing the distributed workflow and responsibilities involved with microservices. The next one is security risks from rapid container scaling if not monitored properly. The rapid scaling of containers can introduce security risks if not monitored appropriately. Next one is complex interdependence or functionality issues when transitioning from legacy applications to microservice architecture. Microservices architecture can result in complex interdependencies or functionality issues. And the last one is dependency of certain microservice on specific machine capabilities or operating system. Require capabilities inclusive to certain machines such as computer, GPU, or SSD, making them dependent on a specific type of operating system or machine instances.
Containerization and container orchestration, Docker and Kubernetes. What is containerization? Containerization is a form of virtualization where applications run in isolated containers, encapsulating all necessary components such as binaries, libraries, and dependencies, allowing for easy portability and superior agility in software development. Containerization offers a standardized packaging approach for an application's code, runtime, system tools, libraries, and configurations into a single instance, all sharing a common kernel installed on the hardware. There are benefits of containers, including the lightness, where the containers take up a small amount of space on the server than virtual machines, and typically take only a few seconds to start up. Another is elasticity. Containers are highly elastic and don't need to be allocated a given amount of resources. This means containers are able to make more efficient and dynamic use of the resources from the server. Another is density. Density refers to the number of objects that a single physical server can run at a time. Containerizations allows the creation of dense environments in which a host server's resources are fully utilized but not overutilized. Another is the performance, where when there is a high resource pressure, applications perform far better with containers than with hypervisors. Containers offers performance benefits by enabling lightweight, isolated execution environments that minimize resources overhead and streamline application deployment. And last is the maintenance efficiency. With only one operating system kernel, updates or patches on the operating system level only needs to be done once for change to take effect across all the containers. This makes the operations and maintenance of servers more efficient. There are layers of a containerized system, including the infrastructure. Infrastructure is the hardware layer of the container model. It refers to the physical computer or bare metal server that runs the containerized application. Next is the operating system. The second layer of the containerization architecture is the operating system. Linux is a popular operating system of containerization with an on-premise computers. Next is the container engine. The container engine or container runtime is a software program that creates containers based on the container images. It acts as an intermediary agent between the containers and the operating system, providing and managing resources that the application needs. And last is the application and dependencies. The topmost layer of the containerization architecture is the application code and the other files it needs to run, such as library dependencies and related configuration files. So, what is container orchestration? Container orchestration is facilitated by tools like Kubernetes, Docker Swarm, and LXC. Automates the deployment, scaling, and management of containerized applications, enabling developers to automate the lifecycle management of containers without concerns about the underlying infrastructure. Container orchestration uses declarative programming, meaning you define the desired output instead of describing the steps needed to make it happen. Developers, you write a configuration file that defines where container images are, how to establish and secure the network between containers, and provisions container storage and resources. Container orchestration can be used in any computing environment that supports containers, from traditional on-premises servers to public, private, hybrid, and multi-cloud computing environments. There are benefits of container orchestration, and these are reliable application development. Container orchestration tools help make app development faster and repeatable. This increases deployment velocity and makes them ideal for supporting agile development approaches like DevOps. Another is scalability. Container orchestration allows you to scale container deployments up or down based on changing workload requirements. Another is lower costs, where containers require fewer resources than virtual machines, reducing infrastructure and overhead costs. In addition, container orchestration platforms require less human capital and time, yielding additional cost savings. And another is enhanced security, where the container orchestrations allows you to manage security policies across platform and helps reduce human errors that can lead to vulnerabilities. Containers also isolate application processes, decreasing attack surfaces and improving overall security. Another is the high availability. Using container orchestration tools, infrastructure failures can be detected and fixed more easily. If a container fails, a tool can restart or replace it automatically, helping to maintain availability and increase application uptime. And last is better productivity, where the container orchestration boosts developer productivity, helping to reduce repetitive tasks and remove the burden of installing, managing, and maintaining the containers.
So let's talk about the two type of container orchestration platforms. The first one is the self-built one. The self-built one allows the user or gives the user full grasp in the customization, but it has a downside that the user has to manage and maintain the application. So the second one is the managed one. The managed one, in the managed one, the cloud provider is responsible in the installation, in the management, and in the launching of your application. All you need to do is focus on running those orchestrated containers. And next is, let's talk about the difference between containerization and orchestration. So let's talk about the purpose. The purpose of containerization is to package an application and its dependencies into a single container. Sa kabilang banda naman, ang orchestration allows you to automate and manage those containers. So as for the scope naman, containerization focuses more on creating and running applications, while orchestration focuses on a large scale which allows you to orchestrate and automate the management of those containerized applications. Number 3, complexity. So containerization simplifies the packaging and the deployment of applications, while orchestration automates the management and scaling of this containerized application, introducing a higher level of complexity in coordinating multiple containers across different hosts. As for tooling naman, for tooling, containerization, there is this software called Docker, which allows you to package application and their dependencies into a single container. And sa orchestration naman, meron yung thing na called Kubernetes or application na Kubernetes where we can manage those containerized applications. And next, let's talk about the difference between Docker and Kubernetes. So let us first explain what Docker is. So Docker is a platform that enables the developer to package, distribute, and run applications in lightweight portable containers. This container encapsulates all the dependencies needed for an application to run, making it easy and manage the software across different environments. So basically, ang ginagawa ng Docker is to pack yung mga kailangan into one thing called containers and i-run mo through Docker for easier management.
So let's talk about what Kubernetes do. So first, let us read the definition of what is Kubernetes. So Kubernetes is an open source container orchestration platform renowned for managing, automating, and scaling containerized applications. Organizations use Kubernetes to automate the deployment and the management of those containerized applications, yung nasabi sa Docker kanina. So rather than individually managing each container in a cluster, they use Kubernetes to automate and manage those containerized applications.
So in summary, the difference between Docker and Kubernetes is that Docker focuses more on creating and running those containerized applications, while Kubernetes focuses more on orchestrating those containers. Let's proceed to the benefits of Docker and Kubernetes. So first, scalability. So Docker enables easy packaging and deployment of applications into the lightweight containers, while Kubernetes automates those management and scaling of containers, facilitating seamless scalability across the clusters of machines. Second, it is highly available. So Docker ensures that the application consistency and portability across the environments, while Kubernetes automates those deployment and manage those containerized applications, ensuring high availability by distributing the workload across multiple nodes and automatically recovering from failures. So number 3 is portability. Docker facilitates the creation of portable containers that encapsulate applications and their dependencies into a single container, sabi nga kanina. While Kubernetes orchestrates this container across the different environments, ensuring consistent deployment and the management for seamless portability across various infrastructure. So sa security naman, 4. So Docker provides the isolation for applications within the container, while Kubernetes offers features for managing access control, network policies, and secret management, collectively enhancing the security measures to safeguard containerized applications and their environments. So number 5 benefits is the ease of use. So madali lang gamitin ang Kubernetes at Docker at di ka mahirapan. So number 6 is the low cost. By leveraging Docker or containerization, Kubernetes for orchestration and organization. It can optimize the utilization and ultimately leading to reduced infrastructure costs and improve efficiency across the deployment cycle. So, next is agility. So, mapapabilis ang workload natin since we are working by containers, hindi na manually. Because if we do it manually, ang ginagawa natin is to separate those codes for security at yung mga iba pang packets na kailangan. So, by using Docker and Kubernetes, it will increase your working speed and reduce the workload. So, since we are talking about agility, ang last benefit natin is increased innovation. So, yeah.
Good morning everyone, I am Edson J. Malajar and this my topic is about serverless computing, AWS Lambda, Azure Functions, Google Cloud Functions. What is serverless computing? Serverless computing enables developers to write and deploy code without concerning themselves with underlying infrastructures. As cloud service providers automatically manage server provisioning, maintenance, and scaling. Serverless computing enables developers to build applications faster by eliminating the need for them to manage infrastructures. With serverless application, the cloud service provider automatically provisions, scale, and manage the infrastructure required to run the code. In understanding the definition of serverless computing, it's important to note that servers are still running on the code. The serverless name comes from the fact that the tasks associated with infrastructure provisioning and management are invisible to the developer. This approach enables developers to increase their focus on the business logic and deliver more value to the core of the business. Adopting the serverless approach brings a series of significant advantages for developers and businesses. First, automatic scalability. Automatic scalability, instead of worrying about the capacity and infrastructure, the system take care of the automatically scaling the function according to demand. This means that if there is a spike in users and or requests, the service scales to accommodate that demand without manual intervention. Second, efficient payment model. Instead of incurring fixed costs for keeping servers active all the time, with serverless, you only pay for the actual runtime of your function. If your function runs for a few milliseconds, that's what you pay for. Third, agile development. Team can focus on writing code and business logic without the distraction associated with managing infrastructure. This can speed up the time to market and improve team efficiency. And the last is reduce maintenance. Without the need to manage servers, team avoid tasks such as applying patches, updating software, or solving hardware problems. The cloud provider handles all of this behind the scenes. What is serverless function according to provider? AWS Lambda. Amazon Web Services Lambda is widely used serverless solution deeply integrated with AWS services like DynamoDB, S3, and Kinesis, supporting multiple programming languages including Python, Node.js, Java, C#, GoRuby, and custom runtimes for developer flexibility. This solution is one of the most popular in the serverless space, being one of the first to be introduced in the market. Lambda is deeply integrated with other AWS services, allowing developers to easily connect their function with databases like DynamoDB, storage systems like S3, and streaming services like Kinesis. Azure Functions. Microsoft Azure offers serverless computing with seamless integration with various Azure services and support languages including C#, Java, JavaScript, TypeScript, Python, and PowerShell, appealing to users leveraging Microsoft ecosystem. Its proposal for serverless computing allows developers to integrate their functions with a wide range of Azure services, from databases to artificial intelligence tools. The deep integration with Microsoft ecosystem make it attractive for those already using tools and services from this platform. And the last is Google Cloud Functions. Enable developers to build event-driven application within the Google ecosystem supporting languages such as Node.js, Python, and Go, with capabilities to respond to events from Firebase, Google Cloud Storage, and PubSub. It's serverless execution environment for building and connecting cloud services. Google Cloud is a suite of public cloud computing services offered by Google. The platform includes range of hosted services for compute, storage, and application development that run on Google hardware. Google Cloud Services can be accessed by software developers, cloud administrators, and other enterprise IT professionals over the public internet or through the dedicated network connection.
PHP-RAD pages. In PHP-RAD, pages serve as the central hub for applications development, with corresponding fields created for each page, displaying page properties below the page pane and field properties adjacent to the page pane. Number 1. Page fields. List page field. List is used for listing records from a database. List page contains 5 fields. These are the 5 fields. Number 1, output. Number 2, field name. Number 3, group. Number 4, search. And last, search type. Number 2, page properties. The page field properties enables users to configure queries, page title, actions for before and after page loads, etc.
Page field properties. The page field properties enables users to configure form inputs, list page field view, and view page field view. Modifying user page. From the database section, select users table to display the list of user pages. Select the list page to display list page fields properties. Fields in the list page field can be sorted according to users' preference for record display in a table. This can be done by using the down and up arrow on the left corner of the current view. To modify a user page in PHP-RAD, access the page properties to customize layout, styling, data retrieval, validation rules, and event handling. Among the other configurable attributes, enabling granular control over the user experience and application features. PHP-RAD page design. Layout components. PHP-RAD uses the Bootstrap layout components to position items on the browser view. The Bootstrap uses mobile-first Flexbox grid to build layouts of all shapes using the 12-column system. 5 default responsive features, such variables and mixins, and dozens of predefined classes. Layout components in PHP-RAD page design refer to the elements and structures used to organize and arrange the visual and functional aspects of a web page, facilitating the creation of intuitive and visually appealing user interfaces. View components. View components includes the visual elements of a project. View components in PHP-RAD page design are elements like forms, tables, charts, buttons, and inputs used to display data and interact with users, enhancing functionality and user engagement.
Good morning everyone, I am Ivan J. Globo and I am to continue the topic about page PRAD page design.
Page filter components. Page filter components are essential for enabling users to refine and narrow down the data they want to view or work with. These components include search fields, data fields, drop-down menus, and more, enabling users to filter and narrow down data based on specific criteria. Menu components. Menu components are elements used to create navigation menus including drop-downs, sidebars, tabs, and accordions, facilitating intuitive user interaction and seamless navigation across web pages within the application, providing the intuitive way for users to move through different sections of the application. Record count component. The record count component in page PRAD page design is a feature that displays the total number of records retrieved or present in a specified data source, aiding in providing users in contextual information about the dataset being displayed. It will help them understand the scope of the data being presented. Chart component. It empowers developers to visually represent data through various chart types, enhancing data comprehension and analysis within the application interface, making it easier for users to interpret and analyze data through graphical representations. Subpage component. Include list of all tables in a database. For each of the database table listed under the subpages contains their list, view, add, and edit pages which can be dragged and dropped as subpage to a page. This subpage can easily drag and drop onto a page, allowing for efficient organization and navigation within the application.